because like we just said, okay, we're going to find that the reflexes are going to occur for all muscle, okay, and glands. So if we have everything in place, if we've got the stimulus, if we've got the components, which we do, nerve endings, nerves, working muscles, that sort of thing, well, reflexes can and will occur. Reflexes can include, now this is going to come back when we get into that endocrine system, because if an area of the brain that becomes real important with the endocrine system is the hypothalamus, okay? So we're going to find that we're going to see that it can include glandular secretion, but I also mentioned like sweat glands and oil glands, for example, okay? And then, of course, our 3 types of muscle, which I keep trying to point out. The now I can't remember, skeletal, our smooth, and our cardiac. And when we talk about a reflex that involves skeletal muscle, we're going to say that we're having a somatic reflex. And remember, soma always refers to body, all right? So, reflexes involving the somatic nervous system, meaning we're going to see those peripheral nerves be involved, okay, and our skeletal muscle. The pathway that is involved for a reflex to occur, they call it an arc. Like somebody who welds, if you know anything about welding, they have a welding arc that occurs, and an arc is the way the way things are moving. Okay? So, in a somatic reflex, skeletal muscle reflex, okay, we'll have a receptor that can pick up the stimulus. So, those receptors that can pick up the stimulus can be in the skin, they can be in the muscles, or they can be in the tendons. We will have an afferent nerve fiber, meaning it carries the information to the posterior horn. You remember the little butterfly thing that existed? Okay, and you remember how on the posterior side looked like those rootlets came in to the horns on that side? So it takes it to the posterior horn of the spinal cord or to the brain stem. That will come into play when we talk about our viscera. Okay? We have an integrating center. In skeletal muscle, reflexes that are going to occur, for the most part, the integrating center is going to be the area of the spinal cord where the stimulus enters. So if I'm walking along and I bump my toe, that stimulus goes to the lower parts of my spinal cord. This is where I get my response. If I touch something hot, we're entering at another point on my spinal cord. It integrates and sends the response. The brain registers it, but my response is not coming from the brain. It's coming from the area of the spinal cord where it entered. Cranial nerves will have the ability to hear. Okay? So, where the synapse occurs in the gray matter. Now, if I look at my spinal nerve that's entering, and if that sensory information goes in on that posterior side, the gray matter is made up of nerve cell bodies. Do you guys remember that? Okay, so I've got some nerve cell bodies in this area of the gray matter, okay, and then it has the ability, okay, to integrate that information that came in, give me a response out to carry out pulling away or whatever the case might be. And it did not need, if this is a cross section of my spinal cord, it didn't need to go all the way up to the brain. It will, but by the time it's gotten there, I've already gotten my effect to pull away. Does that make sense?
Yeah, are reflexes the only ones that can happen just in the spinal cord without going up to the brain?
Well, information will get up there, but by the time you're even aware, okay, the response has already occurred. So that response came from the integration that occurred right here at this level of the spinal cord.
Mm-hmm. But are reflexes the only time when that happens?
Yes. Yeah. Mm-hmm. Okay, so that's okay.
Random question. Is there any way to improve reflexes?
Is there any way to what?
Improve reflexes, like improve reflex time or anything? Like, is there any way to
Yeah, mainly because when reflexes occur, we are not consciously aware. Now, does that mean, we know that over time, okay, as we get older, reflexes are weaker and take longer and that sort of thing. But that's due to a lot of other physiological factors that are taking place. Like, for example, collagen is very important to muscle tissue, connective tissue, and so forth. And as we get older, that breaks down. Okay, so that would mean whatever it's functioning with will cause it to not function as well. So there are other physiological factors that happen that could affect that particular response. The integrating center will determine if we need an effect. So say, for example, all right, we touch something hot. Well, first of all, we don't want to leave that hand or the fingers or whatever the case might be on whatever's hot, because we begin to burn and injure our skin, which is our first line of defense. And so the body wants to protect that, so it will integrate and it will give an effect, and it will cause the muscles that need to work to make the hand pull away. So if it determines that we need an effect, efferent nerve fibers carry those directions to those muscles. Okay, so we would see from that anterior side those directions to move that muscle to occur. And the effector, okay, the pieces of the body that have to carry it out would be an effector. Okay, so my skeletal muscles are effectors. So if all of this is present, all of this is working to a normal level, reflexes are going to occur. And of course, one of probably the easiest reflexes to think about is the knee-jerk reaction. All right, and the knee-jerk reaction. That's because that's usually one that a doctor's going to do very quickly. Okay, I don't know why. I don't really like it a whole lot. Okay, I don't know if maybe it's because the tendon and everything is a little more sensitive for me or whatever. But hey, I still get the effect. But what we're trying to see in this picture, when a reflex occurs, we create an arc. And an arc usually does this number. Okay? We usually have something going in and something coming out. So we create an arc. Note what they're trying to show us in the picture. Okay, so go to the doctor. They're like, well, let's check those reflexes. You sit up, got your feet hanging off. They come over with a little hammer. You got to wonder sometimes if maybe they just enjoy doing that. But they come over with a little hammer. What do they normally do first? Do they kind of do this number to you, where they're feeling? They need to determine where to hit. Okay? Because if you don't hit it in the right spot, well, first of all, it might hurt. Okay? And then you're not getting the response that you need. So they actually have to feel for the patellar tendon. That's the part that they need to hit. Okay? I shouldn't say hit. They need to tap, rather, toughly. Okay? So they'll come over, they'll hit the tendon. Now, that tendon, is it not connected to a muscle? Because what do tendons do? We're going to see that we have connections between muscle and bone. Okay? Now, I have a connection to a muscle. All right? It's going over my patella. All right? In the muscle, which I mentioned earlier today, in part 1, I hope you learned that not only in tendons, but in muscles, you've got little specialized structures. Those specialized structures are there to help with picking up information like this. For example, the tap on that tendon pulling on that muscle. And that muscle has specialized muscle spindles to pick up on that. And it recognized, uh-oh, something made that muscle move. That's not the proper orientation for that muscle. Let me pull it back. And isn't that what happens? Gets hit on the knee, kicks out, the body goes, hold up. Nope, that's not the correct position, and makes you bring back. So it has all those little specialized parts that are picking that up before we even know it. And it corrects the position of the body. So if we look at it in relationship to the muscle, the skeletal muscle, my arc that's getting created, I have in that muscle a specialized muscle spindle that picks up the information. There's my receptor. My receptor has a fiber, an axon, that will send it by way of the spinal nerve, okay? And if we're talking about the leg here, we're looking at the lower parts of the spine, okay? It'll send that information through my dorsal root and into the horn on the dorsal side, and what do and they're trying to represent the